Okay, so in this class, we will discuss about statistics, that is in class 11 portion, and also it's a very good topic for the JEE mains point of view. Every year, every slot has one question at least from this particular chapter. All right, so I have already covered it in the Enable Plus classes, but now it was due in weekend classes, so we will be doing it here again. So first of all, this is actually the real maths. Statistics is the real mathematics that we will be dealing in our daily life. In like companies use it too much to set up their data, to analyze their situations. So this actually happens in the real world. So the terms here that we frequently use is the, first of all, it is measure of central tendency. Measure of central tendency. So this is a value that describes the characteristic of the entire data. Getting my point? This is a value which describes the characteristic of the entire data. Like if you take it like there is a scores of a batsman in 5 matches as you say 7, 8, 9, 10 and 12. So what generally you will say? That the score of the batsman is revolving around 9 or 9.5? Yes or no? Score of the batsman is somewhere around 9 or 9.5. So that is what we call the measure of central tendency. Understood? So that 9 or 9.5, that is kind of some average or some value around which the entire data is revolving. So that is what we call central tendency. Understood? So a value which describes the characteristic of entire data is called an average or a central value. It's called an average or a central value. Generally, an average lies in the central part of the data and is therefore such values are called central tendency or measure of central tendency. Got it? So the most frequently used measures of these central tendencies are arithmetic mean, median, and sometimes mode also. These geometric mean and harmonic mean are not so frequently used while calculating the measure of central tendency. We'll plan to discuss about them also, but first of all, my main priority is arithmetic mean, median, and mode. Now, what is mean? Mean or arithmetic mean? Mean is simply nothing, sum of all the observations divided by number of observations. Getting my point? Now, if the observations are like x1, x2, up to xn, be the n observations, then mean is given by x1 plus x2 plus x3 up to xn upon n. That is sigma xi upon n. Just as an example, if I take, say, 1, 2, 3, 4, up to n. These are the first n natural numbers. Then their mean will be what? Mean will be 1 plus 2 plus 3 up to n whole divided by n. So the answer will be n into n plus 1 upon 2 divided by n. This is cancelled. So it is n plus 1 upon 2. This is the mean of the mean of the first n natural numbers. Now, if I have data like 1 square, 2 square, 3 square, 4 square, and so on up to n square, then mean is what? 1 square plus 2 square plus 3 square up to n square whole divided by n. So that would be n plus 1, 2n plus 1 upon 6 also divided by n. Now, n and n cancel. So, your mean is n plus 1 into 2n plus 1 upon 6. Understood? If I have n odd numbers, 1, 3, 5, 7, up to 2n minus 1. These are what? First n odd natural numbers. In that case, mean will be 1 plus 2 plus, sorry, 1 plus 3 plus 5 up to 2n minus 1 whole divided by n. If you calculate this sum using AP of the above sequence, it will come out to be n square upon n. So mean is exactly n. Understood? So this is what? Mean of the first n odd natural numbers. Now, arithmetic mean, if we have the frequencies of n observations, if the corresponding frequencies or m of n observations x1, x2 up to xn is f1, f2, f3 up to fn. So if take it like I just give you an example. Say these are the scores in a say class test, and these are the number of students. So say 12 marks have been scored by 6 students, 14 marks scored by 5 students, 15 marks scored by 7 students, 17 marks scored by 3 students, and 19 marks scored by 2 students. Say these are the scores. That means this observation 12 has frequency 6. Means this score 12 is coming 6 times. 6 different students got the score. Sorry. So 6 different students got the score 12. Then there are 5 students who got the score 14. Then there are 7 students who got the score 15. Then there are 3 students who got the score 17. Then there are 2 students who got the score 19. So this is what we call frequencies of the score. So in that case, mean comes what? Mean is f1 x1 plus f2 x2 plus f3 x3 up to fn xn divided by f1 plus f2 plus f3 up to fn. Am I clear? See, if you will like do it in a very normal way, then x bar will be what? You will be adding, say 12 plus 12 and so on 12. How many times? 6 times. Then you will be adding 14 plus 14 up to 14. How many times? 5 times. Then you will be adding 15 up to 15. How many times? 7 times. And so on so forth. And then divided by total number of students. Total number of students. And that is why this formula has been designed. Like you multiply x1 f1 number of times. You multiply x2 you multiply x2 f2 number of times and so on so forth. Understood? So now this is not really geometric mean and harmonic mean we'll do later on if required. Now come to the another important point, that is median. Now median is what? If all the observations like x1, x2, xn are arranged in their ascending order or in their descending order. Got it? Like an observation that I have is 2, 3, 4, 7, 8, 17, 18. Like this. 1, 2, 3, 4, 5, 6, 7. There are odd number of observations. So if all the observations that we have, if I arrange them in the ascending order or in the descending order, so the exactly central observation, this. Exactly central observation, this. This is what we call median. Am I clear? Now let us take if the observations are like 2, 3, 4, 7, 8, 17, 18, 20. Now there are even number of observations. So whenever there are even number of observations, In that case, there will be two observations coming in between. Then their mean of these two observations is what we call median. Mean of these two observations is what we call median. So let x1, x2, xn be the n observations arranged in their ascending or descending order. Then if n is odd, then median is what? N plus 1 upon 2th observation. Got it? And if n is even, then median is what? N by 2th plus n by 2 plus 1th observation and mean of that. So if n is even, then n by 2th plus n by 2 plus 1th observation, exactly two observations in the middle. Getting my point? So if n is even, then exactly two middle observations, mean of that is what we have, median. Got it? Now, if median is like, if data is in class form, like 10 to 20 marks scored by this much number of students, 20 to 30 marks scored by this much number of students, and so on. In that case, formula for median is, that is L plus n by 2 minus C. The C is what? CF, cumulative frequency, divided by F into H. Now the terms are like, L is lower limit of the median class. F is what? Frequency of the median class. H is what? Size of the median class. C is what? Cumulative frequency of the class preceding the median class. Cumulative frequency of the class preceding the median class. So this formula you have to remember. There was a question in JEE Mains, write using this formula this year only. 2024 last year means. Now see, there is an example for this. The median of the following data is 525. Median is what? 525. Median of the following data is 525. Find x and y if total frequency is 100. Got it? So first of all, I will add this entire data. See, now I will make another column for, first of all, cumulative frequency. Cumulative frequency. Now see, cumulative frequency up to this point is 2. Then it came 2 plus 5, 7, at 12. 12 if I add, then it is 19 plus x. Then add 17, that is 36 plus x. Then add 20, 36, 46, 56 plus x. Then add y. So it will be 56 plus x plus y. Then add 9. 56 and 9 is 65 plus x plus y. Then add 7. Adding 7 means 65 plus 7 is 72 plus x plus y. And finally you add 4. So then you get 76 plus x plus y. So here sum of all the frequencies is what? 76 plus x plus y. So one thing they are providing you is 76 plus x plus y is equals to 100. Means x plus y is 24. This is the one data that you are having. Now they are saying median of the following data is 525. So if median is 525, that means it is coming into this class. So this is what I define as median class. This is what we call median class. Now, median is, they are providing 525. So the formula for median is L plus n by 2 minus CF, cumulative frequency, divided by frequency into X. Got it? So L is what? L was what? L is lower limit of the median class. So lower limit of the median class is 500 plus. N by 2 is what? N by 2 is frequency of the, sorry, N by, F is frequency of the median class and N is total the sum of all the frequencies. So they are saying total frequency is 100. So n by 2 is 50 minus cumulative frequency of the CF is what? Cumulative frequency of the class preceding the median class. So this is the class preceding the median class. Its cumulative frequency is 36 plus x. 36 plus x divided by f. F is what? Frequency of the median class 20 into h. H is what? 100. H is what? H is size of the median class. So it is from 500 to 600 means size is 100. And it is 525. 525. So now it will be 25 is equals to, this goes 5 times, 50 minus 36, 14 minus x into 5. So 14 minus x is equals to 5. So x is what? 9. Now x plus y is 24 you are having. So if x is 9, y will be 24 minus 9, that is 15. X is 9, so y is 15. Understood? So this is what I call cumulative frequency. Sorry, this is what values of simply values of x and y. And this is how we use this formula for the median for continuous frequency distribution. Understood? Have a look. Take a moment. Have a look at it. Understood? Now let's come to mod. Mod is what? Mod is the measure of central tendency where we are looking for the observation which is very frequently repeating. Got it? So mod is what? It is the measure of central tendency where we are looking for the observation which is very frequently repeating. Like in the discrete frequency distribution, if I have a data of 2, 2, 2, 3, 4, 3, 3, 3, 3, 5, 8. Got it? Now, if you see, this 3 is repeating 5 times and repeating maximum number of times. So in that case, mode of this data is going to be 3. Mode of this data is going to be 3. Now, if we are in the continuous frequency distribution, so in a continuous distribution, the interval which has maximum frequency is called modal class. And in that case, mod is what? Mod is L plus F1 minus F0 upon 2 F1 minus F0 minus F2 into H. So this is the formula to find the mod. Where L is what? Lower limit of the model class. That was exactly same lower limit of the median class while we were trying to find the median. F1 is what? Frequency of model class. F0 is what? Frequency of the class preceding the model class. F2 is what? Frequency of the class succeeding the model class. And H is what? Class size. Got it? So this is a formula that you have to remember. There's no other way around for it. Formulas are there. We have to remember. Now see here. A survey conducted on 20 households in a locality by a group of students resulted in the following frequency table for the number of family members in a household. So it is like, now if you see, this is going to be your model class because it is having the highest frequency. Means these are the observations. There are 3 to 5 family size having the maximum number of families. So this is your model class. Model class is 3 to 5 with frequency F1. I'll use the same notification or notations. F1 as 8. Now in this case, F naught is what? Frequency of the class preceding the model class 7. F2 is what? Frequency of the class succeeding the model class, that is 2. L is what? L is lower limit of the model class, that is 3. H is what? Size of the model class, that is 2. So mod will be what? Mod will be L plus F1 minus F naught upon 2F1 minus F naught minus F2 into H. This is the formula. L plus F1 minus F naught upon 2F1 minus F naught minus F2 into H. Now you just put all the values. So L is what? 3 plus F1 is 8 minus 7 upon 16 minus 7 minus 2 into H. H is what? H is 2. So it is 3 plus 8 minus 7 is 1. 16 minus 9. 16 minus 9, 7 into 2. So it is 3 plus 2 by 7. So it is 23 by 7. 23 upon 7. Understood? So this is what we call mode in case of continuous frequency distribution. Now we will talk about measure of dispersion. This is the most important portion of this chapter. Measure of dispersion. Now, first of all, dispersion is what? Dispersion is, it should be less for a data to be a good data. First of all, which is good? Dispersion, more dispersion is good or less dispersion? It should be less for a data to be a good data. Dispersion is what? That how much a data is deviated. How much a data is deviated from its mean. Understood? How much a data is debited. Like I give you an example. The runs scored by a batsman in first 5 matches of his career are 8, 9, 10, 11 and 12. Now there is another batsman. Now there is another batsman whose scores are like 6, 8, 10, 12 and 14. Now there is a third batsman whose scores are like 4, 7, 10, 13 and 16. If you see at all of them, mean in this case will be 10. Mean in this case will also be 10. Mean in this case is also 10. So mean in all the 3 cases is 10. But if you see, this will be considered as a very good data. This batsman will be considered as a good batsman because he is least deviated from its mean. So mean is 10, he is 1 or 2 runs deviated from that mean. But here in this case, if you see, this batsman we can say is very unpredictable. He may score 14 runs, he may score 6 runs with a mean maintaining 10. Now, if I go for this batsman, this is even more unpredictable. He is getting 4 marks, 4 runs in one match, 16 runs in another match with maintaining mean as 10. So this will be considered as the best batsman with very less deviation from its mean. This will be little less better. and this is not a good batsman because its data, its scores are highly deviated from its mean. Got it? So a measure of dispersion is designed to state the extent to which the individual observation vary from their average. Measure of dispersion is designed to state the extent to which the individual observations vary from their average. Got it? So the commonly used measure of dispersions are what? Range, mean deviation, and standard deviation. Now, range is very simple. It is the difference between maximum observation and the minimum observation. Like in this case, first case, range will be 12 minus 8, 4. In this case, range will be 14 minus 6, 8. And in this case, range will be 16 minus 4, 12. See, more scattered data, more will be the range. More will be the range, less good data. No, that means it won't be good data. Understood? So, lesser the range, better the data. So, the difference between the maximum and minimum observations is called range. And range is what? L minus S. L is what? Maximum value of the observation. S is what? Minimum value of the observation. So, this is the first data which is used to see the dispersion. Now there comes mean deviation. Mean deviation. Simply how much a data is deviated from the mean. So if you have observations like x1, x2, x3 up to xn, then data is x1, x2, x3 up to xn. Now you calculate mean. Mean is what? X1 plus x2 plus x3 up to xn whole divided by n. Now we will find the deviations. x1 minus x bar mod, x2 minus x bar mod, x3 minus x bar mod, and so on, xn minus x bar mod. These are what? These are the deviations. Now, mean of these deviations is what we call mean deviation. So it is x1 minus x bar mod plus x2 minus x bar mod and so on, xn minus x bar mod whole divided by n. Understood? x1 minus x bar mod, x2 minus x bar mod, and so on, xn minus x bar mod whole divided by n. Now, there are two types of deviation generally we talk about. One is mean deviation about mean. And this is what? Sigma xi minus x bar mod upon n. I varies from 1 to n. And then there comes mean deviation about median, that is sigma I from 1 to n xi minus m mod whole divided by n. So mean deviation about mean may we see the deviations from the mean. Mean deviation about the median, we see the deviations about the median. And similarly, there is a term mean deviation about the mod where we see the deviations from the mod. Now, if the corresponding frequencies of the observations are f1, f2, f3 up to fn, then mean deviation is what? That would be fi into xi minus z or x bar whole divided by total number of observations or sum of all the frequencies. Now this z can be mean if we are finding the mean deviation about the mean. This z can be mod if we are finding mean deviation about the mod. This z can be median if we are finding mean deviation about the median. Understood? Now there is a term standard deviation. Standard deviation is simply what? Root mean square of deviations. See, your data is x1, x2, and so on xn. Their mean is x bar is x1 plus x2 plus x3 up to xn whole divided by n. Now their deviations is x1 minus x bar mod, x2 minus x bar mod, x3 minus x bar mod, and so on xn minus x bar mod. Now root mean square. Under root of the mean of squares, that means x1 minus x bar whole square, x2 minus x bar whole square, and so on xn minus x bar whole square whole divided by n. Root of the mean of squares of the deviations is what we call standard deviation, is denoted by sigma. Understood? And if we expand this sigma, it will be like sigma I from 1 to n xi square minus 2xi x bar plus x bar square whole divided by n. Now, see, sigma xi square upon n is separate. If you simplify it, you get x bar square. That is this thing. And there's one thing that I always plan to remember here is what? Under root of mean of squares, minus square of mean. Mean of squares minus square of mean. So it is easy to remember and you will definitely never forget it. Mean of squares minus square of mean. So definitely again same thing. If the corresponding frequencies of observations are f1, f2, f3, fn, then standard deviation is what? Sigma I from 1 to n fi x bar minus xi whole square whole divided by n. And again finally mean of squares minus square of mean under root of that. There is a term also that is what we call variance. Variance is nothing but this is the square of the standard deviation. So the square of standard deviation is called variance and is denoted by sigma square. There is a term also coefficient of variation which is very less used but still sometimes it is used. So we should be aware of that. That is standard deviation upon x bar into 100. So this is what we call coefficient of variation. Now see, there is a simple question. Let alpha beta belongs to R. Let the mean and variance of 6 observations minus 3, 4, 7, minus 6 alpha beta be 2 and 23 respectively. The mean deviation about the mean of these 6 observations is. Got it? So first of all, their mean is what? 6. That means minus 3 plus 4 plus 7 minus 6 plus alpha plus beta whole divided by 6 whole divided by 6 is equals to 2. So that means alpha plus beta plus 2 is 12. So alpha plus beta is what? 10. One relation you got. Understood? Now their variance is 23. Now 23 means variance is what? Mean of squares, So minus 3 square plus 4 square plus 7 square plus minus 6 square plus alpha square. Just a moment. Plus beta square whole divided by 6 minus mean of squares minus square of mean. Square of mean is what? 4. Understood? Now it is 27 into 6 is what? 9 plus 16 plus 49 plus 36 plus alpha square plus beta square. Understood? So your alpha square plus beta square is what? 27 into 6. That is 160. Just a moment. 27 into 6 is 162 minus 36 plus 49. 85, 85 and 16 and 9, 25, 95, 105, 110. So your alpha square plus beta square came as 162 minus 110. That is 2, 5, 52. Now they're asking for mean deviation about the mean. For that, I need to have the data. So alpha plus beta is 10, alpha square plus beta square is 52. So alpha plus beta whole square is going to be 100. So that is alpha square plus beta square plus 2 alpha beta is 100. So from there you got alpha beta as 48, 24. So alpha beta is 24 and alpha square plus beta square is alpha plus beta is 10. So alpha and beta will be 6 and 4. 36 and 16, 50. Yes, correct. So these are your alpha and beta. 6 and 4. Now your data is minus 3, 4, 7, minus 6, 6 and 4. Now they are asking for mean deviation about the mean. So mean was what? Mean was 2. So deviations from the mean are 2 minus minus 3 mod, 2 minus 4 mod, 2 minus 7 mod, 2 plus 6 mod, 2 minus 6 mod, and 2 minus 4 mod. 1, 2, 3, 4, 5, 6 whole divided by 6 if I find the sum of these variations. And this is what? Mean deviation. So this will be 5 plus 2 plus 5 plus 8 plus 4 plus 2 whole divided by 6. So that is 5 and 5, 10 plus 10, 20 and 26. 26 upon 6. That is 13 upon 3. 13 upon 3 is your correct answer. Understood? Have a look at it. See quickly. Easy question it was. Now see, these questions that do not have too much of scope. There is a very limited variety, and a question that comes. This question was from JEE Mains 2024, one of the rounds. So there is very good scope of making correct answers. Understood? Now, let's go for another question. The mean and standard deviation of 20 observations are found to be 10 and 2 respectively. On rechecking, it was found that an observation by mistake was taken 8 instead of 12. Means you were supposed to take it 12, but you took it 8. So the correct standard deviation they are asking for. So the mean and standard deviation of 20 observations. So that means x1 plus x2 up to x20 divided by 2. So mean is 10 by 20. Means x1 plus x2 up to x20 is what? 200. Now, one observation was taken 8 instead of 12. Means you were supposed to take it 12, but you took it 8. So new sum of data or new sum of observation should be 200 subtract 8 plus 12. That is 204. So new mean is what? New mean is 204 upon 20. That is 102, 10.2. That is 10.2. Now you are looking for standard deviation. Standard deviation is what? X1 square plus x2 square up to x20 square whole divided by 20. Mean of squares minus square of mean. Mean was 10, so its square was 100. It will be 4. Standard deviation is 2, so variance will be 4. In that case, x1 square plus x2 square up to x20 square is what? 104 into 20. So that will be 2080. Now new squares of observations is what? 2080 minus subtract 64 and add 144. Understood? So it is 2080 plus 80. That is 2160. So correct standard deviation is under root of mean of new squares. So that is 2160 by 20 minus square of new mean, that is 10.2 whole square. So that would be under root of 10. This is cancel 103 square. Only 103 minus 10.2 whole square. Got it? So it will be 103 minus 10.2 square. 103 options are 3.96, 3.86. No, it's not 108. Sorry. 108 minus 10.2 square. That is 3.96. So it is what? It is under root of 3.96. So this is your correct answer. Have a look. Very good question. This is the most repeated variety of problem. Like 1 or 2 observations taken wrong instead of this correct observation. Now find the correct mean, correct deviation, correct standard deviation. That's it. So this is the most repeated variety. And this is the only way to do it and correct it. Have a look. Now See this question. ABC belongs to natural number. A less than B less than C. Now, let the mean deviation about the mean and the variance of 5 observations 9, 25, AB, CB, 18, 4 and 136 upon 5 respectively. Then 2A minus B, 2A plus B minus C they are asking. So, see completely I won't do, but what you have to do? Mean given to you 9 plus 25 plus A plus B plus C by 5. It is 18. Now mean deviation about the mean. Mean is what? 18. So 18 minus 9 mod plus 18 minus 25 mod plus 18 minus A mod plus 18 minus B mod plus 18 minus C mod whole divided by 5 is given to you 4. So that means magnitude of 18 minus A plus 18 minus B plus 18 minus C is 5 for the 20 minus 9 minus 7, 9 and 7, 16. So 20 minus 16 is what? 4. Now, and variance. Variance is given to you as 136 upon 5. That means 18 minus 9 square. 18 minus 9 square, 81 plus 49 plus 18 minus A square plus 18 minus B square plus 18 minus C square whole divided by 5. This is given to you as 136 upon 5. Is 5 cancel. So 18 minus A square plus 18 minus B square plus 18 minus C square is 136 minus 81 and 136 minus 8 and 5, 130. So that is 6. Now using this equation and using this equation, that is A plus B plus C is 18 5 is 90 minus 34. 90 minus 34 is 56. So using these three observations, you are going to find the values of ABC, which is now not very difficult to figure out. All right. Okay, students, this is not such a huge chapter.